All right, welcome back, students. We're now in lesson 13. This is video 13A. We're going to look at the binomial model. So let's get right to it with an example. Every time you drive to campus, let's say that you try to get a spot down in the lower lot. Usually you fail, but you keep trying. And so from long-term experience, let's say that we know there's a 25% chance that you get a spot in that bottom parking lot. Your full schedule dictates that you come to campus 5 days each week. Okay, so when you drive into campus, there are two possible outcomes. One would be that you get a spot in that lower lot. One would be that you don't. And so there are two possible outcomes each day. Generically, we call these two outcomes a success and a failure. So with the binomial model, we'll always have two outcomes. Binomial means two. And one of the outcomes will label a success, the other will label a failure. They are just labels. It doesn't matter which one you call a success and which one you call a failure, but it sort of makes sense for this one to call a success that you get a parking spot in the lower lot. And then our failure will be that you do not. So for failure, we'll call that event F, and you don't get a spot in the lower parking lot there. Okay, so we'll always have two outcomes. We'll identify which one we're going to call a success, which one we're going to call a failure. The probability of a success we'll label that with a lowercase p. Has to be the same for every trial. So it would have to be that every day you come in, that wouldn't change. And so for this example, we said there's a 25% chance that you get a spot. So every day we're going to say the probability that you get a spot is 0.25. 25% chance on Monday, 25% chance on Tuesday, and so on. The probability of a failure we call Q, lowercase q. That's also going to be the same from trial to trial. And it should sort of make sense that if there's only two outcomes, if the likelihood of a success is 0.25, the likelihood of a failure is going to be 1 minus that. So for this one, if there's a 25% chance of getting a parking spot, there's a 75% chance or a probability of 0.75 of not getting a parking spot. That will always be true, that the probability of a failure and a probability of a success add up to 1, since those are the only two things that can happen. All right. Another thing we'll see with the binomial model, our trials have to be what's called independent. So the trials are independent. Okay, so what's that mean? That means that whether or not you get a spot on Monday, that doesn't change your likelihood of getting a spot on Tuesday. Each day, pulling in the likelihood of getting a spot there, it's independent of what happened the previous days. So even if you happen to, by chance, get a parking spot Monday through Thursday, that still wouldn't affect the likelihood of your chances of getting that spot on Friday. When we have situations like this, where we have two outcomes, the likelihood of a success is constant, the trials are independent, we have something called Bernoulli trials. Try to spell that right. And what we're going to be interested in is the number of successes out of n Bernoulli trials. So if I'm coming to campus for 5 days, I'm interested in counting up how many days were I lucky enough to get a spot in that lower lot. And if that's the case, then this whole situation here warrants us using a binomial model. But all these things that we've talked about, all those conditions sort of have to hold true, otherwise we can't use this. Okay, so for the example that we've, excuse me, that we've looked at, we're interested in the probability that we get a parking spot, let's say exactly 2 out of the 5 days that we come to campus 1 week. Exactly 2 successes would mean that we would have 3 failures. Okay, so it would be really nice if we talked about that multiplication rule for independent events. It'd be really nice if, hey, the likelihood of getting a spot on 2 days what if we said, all right, we're parking 5 days. I want to get a spot on 2 days. What if it's 0.25 times 0.25? I've gotten a spot. And how about on the next 3 days I don't get a spot? So the likelihood is 0.75. I could just use that multiplication rule for independent events. If I did that, this would be 0.0264. Maybe I think, all right, I'd like to attempt to solve this way. Again, it would be nice if that was the probability, but it's not. The problem with this is the probability that you got a spot on Monday and Tuesday, but not on Wednesday, Thursday, and Friday. That's not the only way that you can get 2 spots in 5 days. It may have been that you got your 2 spots on Tuesday and Wednesday. And we could write that probability down. For Monday we'd have 0.75. For Tuesday and Wednesday we'd have 0.25. We'd have some more 0.75s. You can see there's going to be a whole different set of combinations of ways that we can get a spot in 2 out of 5 days. Let's figure out how many different ways that can happen. So this is not the answer to this question. This is the likelihood of getting a spot on Monday and Tuesday and not the rest of the week, but not exactly 2 spots in 5 days. All right, so what if we take into account which 2 days we get the spot? Just said there are many ways to get a spot exactly twice each week. Let's list out every possible scenario. So in your notes, I think you have a checkbox here. The one that we looked at, we said we got a spot on Monday and Tuesday, but not the rest of the week. What if we got a spot on Monday, Wednesday? Those were the days. Or we'll stick with Monday and Thursday. Could be Monday and Friday. That takes care of all the combinations with Monday. I'm going to move to Tuesday. Tuesday, you could have gotten a spot Monday, or we could do Tuesday, Wednesday. You could get a spot Tuesday, Thursday, or Tuesday, Friday. Moving to Wednesday. Wednesday, you could get a spot Wednesday and Monday, Wednesday and Tuesday, Wednesday and Thursday, or Wednesday and Friday. And then the only other option here would be the last 2 days of the week, Thursday, Friday. And that's an exhaustive list. If you try to come up with any other combination of 2 days, we've hit them all. That is every single possible way you could get a spot on 2 out of 5 days. So if we count that up, 6, 7, 8, 9, 10, there are 10 ways that you can get a parking spot on 2 out of 5 days. All right, let's talk some more about that. Each one of those ways that we just looked at, I've probably already said this word a couple times, but each one of those different arrangements where we have X successes and N trials, each one of those is called a combination. And I should probably mention here, N trials, for us, the number of trials was 5 days. X is the number of successes. We're looking to successfully get a spot in the lower lot on 2 of those days. And so for this one, each of those different arrangements in which we can have 2 days that we get a parking spot out of the 5 days was a combination. And for us, there were 10 combinations. All right, some of the language that you'll see used in some of the syntax. Each one of those combinations, or the number of combinations that we'll have, there's some notation that we use. We write a lowercase n, a capital C, sort of stands for combinations, and a lowercase x. This is always the number of trials. This is always the number of successes. And we say this is n choose x. N choose x. And this right here is the number of combinations of x successes in n trials. So this more or less is the symbol that we'll see used for this situation here. All right, do we have to make a table every time? We're not going to make a table every time. Seems like there ought to be a formula for figuring this out. For the first one, we looked at a table. But mathematically, could we figure out how many combinations there are of 5 days choosing 2 of them? And there is. So I think this is the next slide. So what's the formula for this? Put that over at the side for now. The formula for this is we take n factorial. You may or may not have seen that. I'll talk about what that is here. And divide by k factorial and n minus k factorial. All right, that n factorial.
X.
Whoops, x, sorry. Some books, if you read them, will do n choose k instead of n choose x. Thank you. You might even see n choose r. But in your notes, we're going to use n choose x. So we want to be consistent with what we're using. Thanks. All right, this may be the next slide, or we put it here. Yep, next slide. What this here is, n with an exclamation point. I called it n factorial. Let's talk about what that is if you've never seen that before, and then we'll compute one of these. So what is n factorial? First of all, we say n factorial. All this is, n's going to be a number. It's going to be the number of trials. And you take that number, and you multiply by 1 less than that number. And then you multiply by 1 less than that. And you multiply by a number 1 less than that. And you keep going until you get down to 1. So as an example, 4 factorial would be 4. One number less than that is 3 times 3. Number less than that is 2 times 1. And 4 factorial is just the product of that. So 4 times 3 times 2. In this case, we get 24. 1 factorial is just 1. And by definition, 0 factorial is also 1. So if you ever end up with a 0 factorial, that's not 0, it's 1. All right, so now let's use that combinations formula. All right, so when we go to compute a binomial probability, we will need to know the value of n choose x. So let's practice. This is the parking lot example. Suppose we have 5 trials. We're looking for the number of ways we can have 2 successes out of those 5 trials. Compute 5, choose 2. We kind of already know the answer is going to be 10, so we'll be able to check our work here. But 5, choose 2. If I think about that formula, it said to put n factorial on the top, x factorial on the bottom, and then also in the denominator, we take n minus x factorial, so 5 minus 2 factorial. Just like in algebra class, you do what's in the parentheses first. So this is 5 factorial divided by 2 factorial, 3 factorial. And now if I write these factorials out, we could solve this. So 5 factorial is 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. And there's nothing wrong if you want to multiply all that out, but save yourself some effort here. I've got 3 times 2 times 1 in the numerator. I've got 3 times 2 times 1 in the denominator. They can cancel out. I've also got a 2 down here. 4 is divisible by 2, so I could make that a 2, cross that out. And now on the numerator, I'm left with 5 times 2, which is 10. The denominator, I just have a 1 left, so this is 10. So there are 10 ways that you could get a parking spot on 2 out of 5 days. So this will definitely save us a lot of time. If we were to track parking over the course of a month, you wouldn't want to do over the course of 20 days, how many ways can I get a parking spot on 4 of those days with the table format. That'd be way too long. So we're going to stick with this combinations formula. All right, I think we have one more to practice. So new problem. All right, in this one, we have a group of 6 students and would like to select 3 of them to go to Taco Bell. So how many ways can we select those 3 lucky students that get to go to Taco Bell? They get to go in the car, and maybe they're not so lucky. Wait in the drive-through line for 45 minutes. All right, so we have 6 students. Essentially, we want to select 3 of them. How many different ways can we select 3 of them? We could get John and Joe and Kim would be one combination, or Kim and Joe and Alketa would be another one. How many different combinations of 3 out of 6 students are there? So in this case, the number of trials that we have a total of 6 students. The number of successes, we would like to select 3 of those students. So we're going to figure out what's 6 choose 3. Okay, so the numerator has n factorial. The denominator has x factorial and n minus x factorial. And again, do what's in parentheses first. So the denominator becomes 3 factorial times 3 factorial. And then I can write these out again. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. Again, it's 3 times 2 times 1. And then cancel out what you can. We've got 3 times 2 times 1 here and here. 3 times 2 is 6, so I could really just cancel that out with the 6. And I'm left with 20 over 1, or 20 ways. And so I'm glad I had listed like 2 of the ways. But you don't want to have to list out all 20 ways for this one. But I know that there are 20 ways that I can select a group of 3 students out of a group of 6. So in this lesson, we just really talked about that combinations formula and started to introduce the concept of a binomial model. In the next couple of lessons, you're going to learn how to use this to compute binomial probabilities. So that's it.